So when there's no time limit, okay, I expect you to try to find a perfect solution, you know what I'm saying? Like not just to roughly know how it goes, like actually write it out and have a perfect solution ready, you know what I'm saying? So let me give you some ideas for this problem. So the main idea I think for this problem is if you learn some basic algebra, you'd know that this is like a sum and difference of two cubes, right? So this is the same as that geometric sequence thing we were doing. It's the same idea. Okay. Plus y. This is x squared minus xy plus y squared. Yeah? We all good with that? So this is how you factorize a sum and difference of two cubes. Okay. And I think what happens next is kind of obvious, but it's also laden with danger. Okay. So the obvious thing you would do here is cancel the x minus y and the x plus y. Yeah? Okay. Alright. And basically anytime you cancel something, for some reason there's always like 80% of the people forget that you can't cancel 0, right? So then you have to assume that x minus y is not 0, x plus y is not 0, and then you have to come back to these cases later, right? And this question is literally like a HSC maths question in the sense it tests you for exactly the same errors, okay? So divide by zeros just come up, okay? Alright. What's next? Well, so I think some mistakes that people made was like plus or minus square roots, right? People only do the plus square root, they forget about the minus square root. Okay. Okay, so let's cancel this, and then you get x squared. So you get x squared plus xy plus y squared equals 7, right? And here is like the question kind of gives you a hint because the question is asking you for this, right? So then you might think of this as separate to the xy, right? So then you kind of have two equations in two unknowns, yeah? And your unknowns just happen to be x squared plus y squared and xy, okay? So one obvious thing you can do is you could add them, yeah? If you add the two equations together, okay, you get 2x squared. The xy minus xy cancel, right? And you get the 2y squared. And that equals to 12, yeah? So that already tells you it's going to be, one of the values is 6, right? So here x squared, so you cancel the 2's, and you get x squared plus y squared equals 6, yeah? Okay, well how many times do you need to add 6? Well, this is where the xy comes in, right? So if x squared plus y squared is equal to 6, then xy here must equal to 1, right? Because 7 minus 6 is 1. Okay. And here is where, like, in school, if you're doing this in school, you might, like, graph it out, okay? So, like, in year 10 and 11, you might be like, okay, well, if I were to graph on the xy plane, x squared plus y squared equals 6, right? What that is, that's a circle. That's a circle with radius squared equals 6, okay? Centered at the origin. So this is minus root 6. Okay. And if I were to graph xy equals 1, okay, that's also something common to school. It's like a hyperbola that looks like this. Yeah? Okay. That makes sense? Okay, and in school, so you can see actually there's 4 intersection points, right? So that means there's 4 solutions that give you 6, so it contributes a total of 24. Okay? So in school, if you did this, it'd probably be considered a proof, okay? But for me and maybe other competitions and other things, this is not a proof, okay? You can't just say intersect, because you haven't proven that they intersect 4 times.
Yeah.
Okay? So you haven't proven they intersect 4 times.
Just proven the maximum intersection time.
Yeah, and so maybe it's like tangent or something, right? There's only one intersection, or maybe there's no actual solutions. Okay, there's actually. Can you see why there might not actually be any solutions?
You're just proving there's 4 complex solutions, right? No.
There might not even be any. There might not even be any complex solutions. Okay. So the point is your solutions also need to be consistent with x plus y and x minus y not equal to 0. Okay? So if your solutions turn out to be x equals y, then they're contradicting your premise, right? So you need to check that as well. And if you check that out, then there should be there should be 4 solutions, okay? But you have to prove it. Okay. Alright, so how do we prove it? So I mean we can go through the quadratic and stuff, but there was a nice little sort of a nice little innovation given by Ryan on Saturday. Okay. That does look kind of clean. So if you have x squared plus xy plus y squared equals 7, right? What you can do is you can add xy to both sides. Okay? Then you get x squared plus 2xy plus y squared equals 8. Right? Because remember we know that xy equals 1. Yeah? Yeah?
Yeah.
And the point of doing that is now this is a perfect square. Okay? So you get x plus y all squared equals 8, right?
Yeah.
And similarly, you can do that over here, and you get x minus y all squared equals 4, right? That makes sense? Yeah, so the good thing about writing it like this, okay, it makes it absolutely clear that x plus y and x minus y are not 0, right? Because they're literally equal to 8 and 4, the square root of 8 and 4, yeah? So they're not 0, okay? But then there's like a bunch of possibility you need to consider, okay? So either x plus y is equal to root 8, or it could be equal to minus root 8, okay? So people losing marks here, okay? Not doing the plus or minus square root. And the x minus y could be 2, or it could be minus 2, right? So there's actually 4 cases you have to solve, okay? So if you look at the 4 cases, so one is x plus y equals root 8, x minus y equals 2, yeah? Then you have x plus y equals root 8, x minus y equals minus 2, x plus y equals minus root 8, x minus y equals 2, x plus y equals minus root 8, and x minus y equals minus 2, yeah? So the point is not that, like, yeah, so I guess the point is that now you can see that, you know, the point is you can see that there should be 4 solutions from this, right? Yeah, so you can explicitly test them, okay? So you have but the question is, does it prove there are 4 solutions? I think to really prove that there are 4 solutions, you might have to be a bit careful, okay? Because at the moment, this is saying like x and y have to be like this, yeah? So it's reducing the number of solutions. It's not saying that the things that come out of this will actually be solutions. Okay, Lucas is here. Okay, yeah, so I'm kind of just cleaning up this thing. So I guess one way you can proceed is you can literally solve these equations, yeah? So for example, this one, you get x, so 2, if you add them up, you get 2x equals 2 plus root 8, and root 8 is 2 root 2.
Yeah.
So then x is equal to like 1 plus root 2, okay? And if x is 1 plus root 2, then, and x minus y is 2, then y is equal to minus 1 plus root 2, you know? Okay. And you might want to check that they are solutions. So for example, how do we do this? So the cube might be a little bit, I don't know, you don't actually have to go all the way cubed if you're assuming x is not equal to y, right? But you might want to, so x, so the most direct equation you can check, like x squared plus xy plus y squared equals 7, right? So if you square x squared here is like, you know, 2 root 2 plus 2 plus 1. So x squared equals 1 plus 2 root 2 plus 2. Y squared equals 1 minus 2 root 2 plus 2. And then x times y is essentially the difference of two squares thing. It's 2 minus 1, right? So it's 1, which is what you want. And so x squared plus y squared is in fact 6, and xy is 1. And so when you add them, you do get 7, right? So you can actually just check that they're all solutions. But the good thing about the quadratic, I guess, is you can say the solutions exist without checking them, because yeah, like you have that, you have the discriminant, okay? But I think this is much more direct, much more straightforward, yeah?
Than what I did.
To check, not what you did. Okay, so if you have 4 solutions, the point is you don't actually have to know what the solutions are. You just need to know there's 4 of them, okay? And so that'll contribute 24 to the total, and it'll contribute 4 to n, yeah? Alright. But then, what about the other solutions? So the other solutions come from us assuming that x minus y is not 0, and x minus y is 0. They're non-zero, right? So then the other solutions come from when they might be 0, right? So when x equals y, or when x equals minus y, yeah? Okay. So when the first thing happens, if x equals y, then this just disappears. It becomes 0 equals 0, which tells us nothing. Okay? And if x equals y here, then you get x cubed plus x cubed equals 5x plus x, right? So then it's 2x cubed equals 5 times 2x, yeah? And because the 2's cancel, you get x cubed equals 5x, right? Okay, and then you get x squared equals 5, okay? Okay, but here's the bit that you got to be careful, because people will be like x squared equals 5, but you've cancelled the x, right? When you cancel the x, you got to make sure it's not 0. Okay. So this is how you lose marks in the HSC. It's kind of dumb. And it's funny because all they have to do is, like, in the HSC, they don't even prepare you for that. That's the crazy thing. Like, that's how they dock you the marks, and there's nothing else to prepare you for and to teach you, but they don't even teach you that. You literally just get in and you start, like, people just start losing marks doing this. And the people who just kind of been careful with maths, they tend not to lose marks doing this. It's quite ridiculous. Okay, so the x is cancelled, but you got to make sure x is not 0, right? So if x is 0, you get a solution 0, 0. Yeah? If it's not 0, then x squared equals 5. Yeah? And if x squared equals 5, then y squared equals 5. Right? So if x squared equals 5 and y squared equals 5, then they add up to 10. Right? Right? But how many ways can x squared be equal to 5? Okay, it has to be plus or minus root 5. Right? Again, you get the minus. That's another way to lose a mark. Yeah? And then y is also plus or minus root 5. Yeah? But the y can't be both plus and minus. It's whatever the same as x is, right? Because x equals y. Okay? So there's literally x equals root 5, y equals root 5, and then there's x equals minus root 5. Oh, I'm writing my files like Liam now. What the? Yeah. Okay, so there's a 10 added twice, right? And you can see the same thing happens when x equals minus y. Okay? But don't count the 0 solution again, because it's already been counted. Yeah? So then you get, so that, if x equals minus y, this thing's 0 now. Yeah? And the other one becomes 2x cubed equals 7 times 2x. So then x squared equals 7. And so it's the same thing, but now it's x equals plus or minus root 7, and y equals minus plus root 7. Yeah? And root 7 plus 7 is 14. So you get 14, 14, 6, 6, 6, 6. Yeah? Yeah, so that total adds up to 72, and there's 9 solutions. Yeah? Yeah, so this is not a very hard question. It's literally a high school kind of maths question, except it's hard to get all the marks because you have to be careful not to lose these. Yeah? So that's why in maths it's kind of like it's pretty important in maths to like to know how a situation goes perfectly, right? It's like how does division work? You are allowed to divide by every number except for 0, right? So that's how the logic goes, right? If you divide by something, you just have to check that it's not 0, right?
Yeah.
Whereas like if you didn't have that idea, it might seem a bit more magical. It's like I divide by stuff until they take marks off, and then I stop dividing by stuff. Like that doesn't really make any sense.
When else, like, how can we
Yeah.
do that?
No, I think a lot of people like they operate on like an experience kind of existence, like they try something as opposed to understanding it perfectly. You know what I mean? They just keep trying it and they see if they lose marks or not. That's kind of like when people like keep asking someone else if what they're saying is right or not. You know what I mean? Because it's like if they agree, then they don't have to think anymore. But the reality is they could all both be wrong and they agreed on the wrong thing, right? Okay, is everyone happy with this? Yeah.